This is lecture 5 in network theory, right? So in this lecture we are going to discuss about the passive elements, right? So we are going to analyze the in depth. So when we are using this resistance parameter and inductance and capacitance, right? So what are the behavior of these parameters that we need to discuss. But before that, in lecture 4 we discussed the classification of sources. So two types of sources will be there: independent and dependent, or we can say controlled. Again, in independent it can be voltage source or it can be current source. Again, in voltage source there is an ideal one and a practical one. Similarly, ideal and practical current sources. Next, the dependent or controlled can be four types. There is voltage controlled voltage source, current controlled voltage source, and voltage controlled current source, current controlled current source, right? This we discussed in lecture 4. In this lecture we are going to see the resistance parameter. So how we need to find either voltage across the resistance or current, how we have to analyze when the resistance is in circuit. The first point you have to remember is how to draw a resistance, right? So many students will draw simply like this, etc., right? There should be some notation about this. When you are starting, this arrow, or we can say the resistance should be in raising mode, or we can say it should be we can say it should be in upward direction, right? Now after 2-3 points or 2-3 turns, the end one should be in the from the bottom to raising end. See, this is starting at this above point and it should be end with the from here only, right? This is the reason why. What is the reason behind this is, suppose if I apply a voltage here, suppose 1 volt, so at this point the voltage will be high compared to at this point. That is, when we see in the circuit, that will be very clear, right? Remember that it should be in a raising mode and it should be in the from the bottom to top, it should be end here, right? So that is the notation for the resistance when we draw in a circuit, right? So generally, if you follow any textbook, it suppose if we is starting here and we end compulsory in this position only, right? So depending on the textbook, so they will use either 2 points or we can say more than 2 also, but always if we start like this, the falling, then he will end with the like this, so raising, so it will come from the top and it will end at the bottom. So but he is the falling one, here will be there always. So that is the notations. Now we will discuss so how to find the current or whatever. So remember, the resistance always it will resist the current flow through that. So generally it is made up of some material, so always it will resist the current flow, right? But before that we will see, so what is the Ohms law in field theory that we have seen, that is the current density is directly proportional to electric field E, right? And J is equal to sigma into E, right? This is, I already told, this is a first form of Ohms law. So it is in field theory, right? So but we need to apply, or we need to derive a Ohms law in circuit theory. So when we are solving the circuits, so we need a different Ohms law, that is circuit in form of circuit theory. That is, so we can solve from this also. We know that J is equal to the current per unit area A, right? And also we know the electric field is the volt per unit length, right? If I substitute here, this will become I by A is equal to sigma into V by L, right? Now if I make V at one side, so V is equal to sigma, so this L is coming here, so L by sigma A, so suppose it is like this, L by sigma A into this current I, right? So this is the Ohms law in circuit theory. That is, so if I replace L by sigma A, suppose V is equal to R into I, right? So what is R here? R is equal to L by sigma into A. That is, this resistance we already discussed this one, right? R is equal to rho L by A or L by sigma A. So that is this is the Ohm's law in circuit theory, right? This is the second form. Then I will write next page, right here. So what is V is equal to I into R? This is the second form of Ohm's law in circuit theory, right? In circuit theory. So I will write a short form of for the circuit is CKT, right? Now if I define a Ohm's law, so what is the Ohm's law? When the temperature is constant, when the temperature is constant, the current I linearly dependent on the applied voltage. That is, I is directly proportional to V. Now what is I is equal to V by R. It can be listed to V is equal to I into R. This is the second form that already discussed, second form of Ohm's law in circuit theory. So the statement, Ohm's law statement should be, when the temperature is constant, the current I linearly dependent on the applied voltage, or we can say linearly varies with the applied voltage, right? So we can define in many number of ways, right? This is the Ohm's law in circuit theory. So second form I'm writing. Now why we say the temperature is constant? That is, R is equal to L by sigma A, right? Suppose this is some material, conducting material, right? Suppose this is a conducting material and it is having length L, right? Now if we vary the temperature, if I increase the temperature, this material length will slightly expand. That is, it will slightly increases the conducting material length. Now if length is increasing, right, so what happens to resistance? Resistance also will increase, right? When resistance is increasing, what happens to current I, right? So I is equal to V by R. When resistance is increasing, current will decrease, right? So that is the effect of this resistance. That's why in the we know that when resistance is very high, the current is very small, or when the resistance is, suppose R is equal to 0, the current is infinity, very high current will flow. When R is equal to very high, that is infinity, the current is 0. So when resistance is very high, there is no current flow. So that is the reason why it is like this, right? Now when we vary the temperature, the conducting material length will increase. So when length is increasing, its resistance will increase. Or we can say the like this: if temperature is increasing, the length of that conductor will increase. When length is increasing, resistance also increasing. When resistance is increasing, so we can say from this expression, sigma, the conductivity will decreases, right? When conductivity is decreasing means what? So the current is slightly will decrease. So the property of this conduction will go on decreasing, so the current will become almost negligible when very high resistance value is there. So this is some property we need to remember, right? Now if this is a conductor, so if I take a conductor, the resistance T, the resistance will depend on the temperature, that is R0 into 1 plus alpha T, right? So if it is a capital T, so that is temperature. So here T is a temperature, right? If T is increasing, the temperature is increasing, so this factor will raise, so that is overall the resistance will increase, right? So that's why the conductors will have positive temperature coefficient. That means positive temperature coefficient meaning is when temperature is increasing, the resistance also increases, right? But when it is in semiconductors, when we discuss in EDC, the semiconductors will have negative temperature coefficient. That is, when the temperature is increasing, the conductivity will increases, right? Or we can say resistance will decrease in that cases, right? So when in conductor, this is a positive temperature coefficient. That is, when temperature is increasing, the resistance also increasing. In semiconductors, it is opposite. Semiconductor will have negative temperature coefficient. That means if temperature is rising, the resistance will decrease, or we can say the conductivity will increase, right? That we will discuss in the EDC. But for the moment, you can remember, in conductors the resistance will increase with respect to temperature, or conductivity will decrease. Opposite in semiconductors, right? So this is about Ohm's law and the for the resistance, right? Now, so we will go further. Now see, other way of Ohm's law we can go. So we found I is equal to V by R. If I replace 1 by R by another parameter which is called conductance, and the units are Mohs or Siemens, that already we discussed, Siemens, right? So that I is equal to G into V. This is the third form of Ohm's law. Right? So this is about this one. Now, so when the Ohm's law valid, always the temperature should be constant. Now next we will see the power and energy in the resistance, right? But before that, we will draw the IV characteristics of resistance parameter. So anyway, this is, we know, that is, it is linearly dependent. So if V is varying, the current also will vary linearly, right? Like this. So slope always positive. This is minus I, right? So IV characteristics is like, so what is I by V is nothing but 1 by R. So it is conductance. So this diagram also can be written in opposite way. That is, if we take V and this is I, right? And the characteristics will be like this. So here the slope is R. Now what is the reason why we have drawn here is, see, the current source cannot exist practically, but voltage source can be. So when you go to lab, you will see the power supply, that is called DRPS, dual regulated power supply, but you never see any current current sources, right? That's why when you apply a voltage across any element, the current will vary linearly if it is a resistance, right? So that's why we need to draw the IV characteristics, right? So, or we can say simply IV plane. Now if you compare with the classification of elements, so this is a linear, so the resistance is a linear. Now the slope is positive, so we can say it is a passive element. And if you see the slopes in this, so generally this is generally called first quadrant, and this is the opposite is third quadrant, right? So in first quadrant and third quadrant slopes are same, then we can say it is a bilateral, and it should be time invariant, right? With respect to time, if the resistance is varying, that is generally we can say useless, right? So it should not be vary with the time also, it should be always constant with the time, right? Now, so in other way we can define like this. Suppose resistance is like this, right? If I vary the voltage V, suppose this is a V and this is current I, right? Now the current is flowing in the from left to right. Suppose if I replace the voltage here, that is plus minus V, the current should also change its direction, that is from right to left should current flow. That is, this is like plus minus. So if I say this is the first quadrant, and if I go to third quadrant also, if I change, the resistance should be same, right? That is a quadrant. That means if voltage is changing is a direction, or if I change the voltage polarities, the current should also change its direction, right? So that is the first quadrant and third quadrant. If the slopes are same, we can say it is a bilateral. Suppose it is somewhat like this, it is not a bilateral, right? Or we can say these are a linear also, because these should be straight line from infinity to infinity. So just remember those points. Next we will see the power and energy in the resistance. Now we know that power P is equal to work done per unit time, right? So this is of P is equal to dW by dt. Now how can we write another way? dW by dq, that is, if what is the work done per unit charge to move, and dq by dt, this is the current I, that is to move unit charge, or the motion of the charge per unit time, net motion of the charge in unit time, which is nothing but this is a voltage V and this is current I, which is nothing but power P is equal to V into I in resistance. Now if I another forms, if I replace I is equal to VR, right? I is equal to V by R, not VR. So it will become V square by R, that is power P. If you know voltage and if you know the resistance, we can find what is the power dissipation across that resistance. Or in other form, if V is equal to replaced by IR, so it will become I square into R. So this is the power across the resistance. Now how it will absorb or how it will dissipate is, so both the resistor R and the current flowing I and the voltage V plus minus V, right? It will dissipate in the form of heat, right? Remember, energy can be created nor destroyed. It will be transformed to one form to another form. So electrical to the heat form it is converting. So that is the resistance. It will be generated some heat around it, right? So this is about the power. So what are the units in SI? Units are watts, right? Watts, right? Now if I want to find the energy, so energy is equal to, now from this dW by dt, so energy means we cannot use E because we already used E for electric field, so I will use the W for energy. So P is equal to dW by dt, right? So if I want the work or energy, so P is dW is equal to P into dt. If I integrate, so I will get both sides, so the d and this will be cancelled. So the energy absorbed in resistor is integration of P into dt minus infinity to t. Now if I know power, I can integrate, but what is the power? So I can replace by minus infinity to t. It can be V square into R dt, that is one form, and it can be minus infinity to infinity, t, I square by R into dt, right? This is the energy forms. Now what is the units for SI units? Joules, right? So this is about the resistance parameter. So you have to know the basic of the resistance always. What is the power, what is the current flow, right? How it is resisting when we polarities are changing, how the current flows, right? What is the energy across that resistance, right? And the IV characteristics or VI characteristics of resistance, right? And the conductor, what is the temperature coefficient, is it positive or negative, right? How the conductivity or resistance varies when the temperature is increasing, right? So that is the about the resistance parameter. In the next lecture we will see about the inductance parameter, right? Now for your benefit, I posted questions on the basic concepts, maybe you've seen, but whoever is watching this video, so they can go to learning is everything blogspot.in, right? So I uploaded questions and answers also. Now you can do first without seeing the answers, and you can match with that. If any, I mean, if I did a mistake also, you can post a comment there, right? If any discussions you want, so you can comment in my blog, right? So in comment section, so that we'll see in that blog, right? So that is about this. So next we will see the inductance parameter in next lecture.